Hello everyone. Thank you for joining rate limiting session hosted by Redis. Today we have our Redis experts to discuss about rate limiting with Redis and the need for rate limiting, especially in microservices environments, as well as several use cases to understand strategies for effective rate limiting. Before introducing our key speakers for this session, I will quickly walk you through the housekeeping notes. The audience is on mute by default. If you have any questions or wish to speak, please raise your hands by clicking the raise hand button at the bottom of your Zoom screen. You can also drop your questions in Q&A session or write to us on chat. We love to keep the session as interactive as possible. The session is recorded and will be shared post the event. Now coming to our featured speakers for the session. Suyog Kale, our in-house expert who has 18 years of experience in software industry. He has extensive experience as a software architect, having worked at various software and product-based companies. He has played a major role in helping banks to certify Redis Enterprise and help in massive migration for traditional cache solutions like Coherence, Gemfire, JVM to Redis Enterprise. He's the author of the book Redis Deep Dive, which is very popular in the Redis community. We also have Abhishek Srivastava. Abhishek is a seasoned software professional having years of experience across industry verticals like e-commerce, BFSI, IoT, healthcare, etc. In his earlier role, he has been involved in various app migration and modernization activities. He's working as senior partner solution architect with Redis and takes care of technical initiatives in Asia Pacific region. And he is one of the popular person with all of our cloud providers like Azure, GCP, and AWS. Welcome you both for today's session. Now I will hand it over to Suyog to take it over from here.
Thank you, Rakila. Good morning, good afternoon, good evening, everyone. Where are you? So I'll start with today's agenda. So today it's going to be an interesting topic. I think this is my another webinar after our feature story webinar we did in maybe May. So today we are going to talk about rate limiting. The first two topics will be more like, what is really a rate limiting, why it is important, and what kind of methods, rate limiting is getting used of, right? We'll talk about Redis and Redis Enterprise for the folks who are new to Redis or maybe, still not clear what Redis can be used for. And then we'll talk about Redis using for rate limiting functionalities. Abhishek has a few interesting videos, how our customers are using Redis for implementing rate limiting and how it can be scaled across multiple regions or data centers implementing these features in using Redis. Okay, and then we'll open up the question and answer session. Yeah, I think Rakila. So now let's talk about what is rate limiting, right? So rate limiting is a technique used to control the rate at which requests are made to your backend system. It could be internet, it could be the network, it could be the other resources, or maybe let's say take an example of an API. Anything at the backend that has set of resources, you want to understand what traffic is coming and how I can control. Depends on type of use case, depends on type of purpose that you want to control the resources, or maybe it is a purpose of how you can charge to your clients, right? One example could be like rate limiting is important for considering the security point of view. How I can protect against the DDoS attacks, how I can basically control the limit of number of requests coming from specific user, or maybe how I can charge the users based on the number of requests that they can make, right? Now, why rate limiting is important? It's very essential today that the way of the traffic has been coming and the applications across different domains are talking to each other. It could be, let's say, example, the payment systems where they are serving the payment functionalities across different types of businesses. Or maybe it's a example, the gaming application, how it's basically serving games across multiple regions. So considering that the first primary reasons comes is protecting the server resources. I want to make sure that the traffic coming to my applications or my servers, I'm able to control over my resource utilization. It could be the CPU, memory, network, or my microservice application that I'm basically implementing scale up and scale down kind of things. DDoS, which basically more as a security point of view, that I want to make sure that particular bots are not hitting to my systems and causing enormous request. Ensuring the fair resource allocation. Imagine the example, I'm implementing job queue and I don't want that to allocate more resources. So maybe at a constant rate, I want to keep the request processing. So I want that kind of limiting to my client request. Mitigating the API abuse or protecting against the bots. This is again like apart from the restricting set of bots to access my application, but also like be considering that how kind of the frauds are happening there and how I can basically limit those access. Managing traffic spikes and maintaining quality of the service. You want to make sure that because of some seasonal reasons or maybe some XYZ expectations in the traffic from the different applications, I want to make sure that it's not going to suddenly cause a demand and it's basically the adding the more latency to my response. So that way I can basically I want to implement rate limiting. Enforcing service level agreements. Example, I have, let's say, set of users. Maybe some users has privileges to access my application more on a priority, or some applications might be has a limited access to my application. So that way I can basically enable types of users and again impose them to the set of access controls. Controlling cost. This is like a subscription based example. I'm implementing APIs which has set of functionalities, and I want to basically give the subscription, like example, maybe the free subscription, premium subscription, gold subscription, and again based on the subscription charges I'm passing to the customer, I'm basically should able to have the control like how many calls they can make into particular time of window or maybe particular type of user base. So this is why the rate limiting is very important. Now let's try to understand types of rate limiting methods. So as I said, that depends on type of application that you are solving, maybe the type of traffic that you are expecting, or desired level of control that you want to give to your application. You need this to choose type of specific type of rate limiting. Imagine I'm implementing backend system which just doing the job processing. I may not need that a lot of scaling of the application. Maybe it will be 2 or 3 applications are sufficient, and then I can just queue those incoming requests. The other use case might be there is a payment solution which might has different types of traffic at let's example in the morning or in the evening there is a lot of payment requests, but maybe in the midnight or something the traffic is big. So maybe that also allows me to design my backend systems. So let's try to understand the first method of rate limiting, which is a fixed window. The fixed window is the simplest way of implementation rate limiting. And I think Abhishek is going to cover this part in his demo. So this allows you to define that every specific period of time, how many requests your application can serve, right? So let's example, every minute I'm going to allow maximum 3 requests. And if more than 3 requests comes in that window, I want to deny that request, right? This is the simplest way. Now, there is a chances that, let's example, you have designed the API, which is going to serve XYZ number of requests. But what if, in the first shot of that window itself, you serve all the requests, then, you will be have like a bad experience because, other rest of the time for that window, there is no request that you can serve. So that you need to make sure that, where I should be using this request, window fixed window kind of a thing. So for Redis kind of customer who are implementing this, we normally suggest them to reduce down the window size to probably a smaller. So maybe not hour or let's example 20-30 minutes. Put it to the small window, maybe 1 minute or maybe 30 seconds, so that you can achieve the better response and good response in terms of serving more requests. Now next. Rolling window. This is also called as a sliding window. It's basically very similar to what we have in a fixed window, but it's basically moving fashion. So based on the last request, let's example, I want to see like how many requests I serve in the last 1 minute or 20 minutes, and how many requests are allowed. I can basically have that design, and then I can decide if there are more excessive requests are coming in a last 1 minute window. Here is the example is that in a one last sliding window, I'm going to allow maximum 3 requests. And if there is a more requests come to that last 30 or 1 minute window, it should simply going to deny the request, right? This is very common implementation, basically, where you basically want to have constant kind of experience for serving the request. This is again one of the very popular method we have seen in the Redis implementation. Next type is token bucket. Token bucket is very similar. Basically, I would say the queuing or streaming kind of implementation. So you're queuing the tokens. So here, what is basically idea here? The every request that you're going to apply backend is going to serve, it needs some kind of a token along with him to allow the request. So what happened? So wherever the request is coming, it's going to check into the bucket that whether the token is available, and if the token is available, it's going to basically serve that request. If the token is not available, the request is going to deny. Now here in the bucket, we are in the backend system, we are adding more tokens periodically, so that let's say example, based on my applications that who can serve the traffic, we are adding tokens, and then applications were basically the requests are coming, they are checking the token is available kind of a thing. So where you have a strict right, kind of that you want to give a SLA that I'm going to serve this many requests per this time, I think this is not the right pattern, because in some cases that if there is excessive request happen and you don't have token available, you will not able to serve the requests, right? Leaky bucket, it's very useful in terms of basically you have constant request traffic that you want to serve and you have SLAs to serve. What it does basically, it create regular flow for serving the request. So what does that mean? It has kind of a queue, which is a kind of a bucket, and then there is a lot of requests coming at a different space. But at the from the bucket, the application which are serving those requests, you can consider as the consumers who are taking one item at a time, and they will be processing that request and sending that response. It is very similar, like implementing least data structures in the Redis is a kind of a LIFO. So from the one side, you are pushing the request, and from other side, there might be one or multiple applications are taking one item at a time and process those requests. It could be very similar. We have Redis stream as well, which also allow you to basically ingest lot of requests at high traffic, and then again you can have consumer or consumer groups who can take items and process those items at their space, right? So that way you can also use Redis streams or list data structures for implementing Leaky Bucket kind of a implementation. Now, this is another type, dynamic rate limiting. It is actually very similar what we see in the fixed window, but here you have more control from the backend, changing that number of request space depends on the scale. Like example, I gave you the example of payment implementation, right? So you know that you know the pattern of your application. Maybe in the morning time and the evening time, you see more peak, and maybe afternoon or in the midnight, you don't see the peak. You can change those rate limiting and control your applications scale up and down kind of thing, right? So here, what it does basically depends on the peak times. You can just change that how many requests you can serve into a specific type of fixed window, right? Now, distributed rates limiting, it is very similar what methods you are using from previous 6 methods we talked about, but it at a distributed scale, meaning that I have e-commerce site, I have gaming application across multiple regions, just deployed across multiple data centers, and I just want to basically control that at geographically. We have many customers who are serving single sign of kind of functionalities or open API kind of implementation with using Redis active. They simply basically scale this across multiple data center. Abhishek is going to cover this implementation with Redis in his one of the demo. Let's go with another poll time. So where we should be putting rate limiting functionalities, right, as a control. So there are two ways. One is the client side and one is the server side. We don't recommend client side implementation. Imagine you have Android applications or iOS applications who are calling your backend, and they have some logic that I can send maximum this request, right? Whether the method that we talked about, but that is not right way, because what if there is a bug in your application? What if there is a, some bot figured out to, send the applications request to your backend? So this is not good in terms of the scale that you can manage and the control that you can have from the backend. So the second approach is the server side. So where basically the rate limiting functionalities or the logic that you're building could sit close to your API server and then serve the request. This is again not scalable. So when you want to really build scalable, independent, which throttle the requests and more like loosely coupled from the API server or your backend implementation, you can implement rate limiting really as a middleware. So it really has minimal dependencies on your backend, how it is scaling, how it's fetching. So it basically becomes a door entry for any client applications to request. And if rate limiting is allowing that request, it can go to your API server. So this is how basically we have seen our most of the customer who use Redis implementation. This is how it looks like. So you have the front end layer, mobile application, web applications, or different client application that contacting to your backends. And then you have Redis rate limiting, where you are basically using Redis different data structures to implement whether it's a fixed window, sliding window, and it will basically serve the request, depends on the request should be allowed or not allowed. Your backend system, because let's example it's a microservices implementation and Redis is a multi-model data structures, you might also using Redis for different kind of use cases, maybe the upstream for messaging, maybe the search and document store for implementing the document catalogs, and there are a lot of other functionalities that you can use at the backend system implementation. So this is what we talked about. What is rate limiting, why it is important, and what type of methods are there. I'll just quickly cover what is Redis and why Redis Enterprise Cloud. So Redis is popular technology. It's available in the community edition, and Redis Enterprise is again a re-architecture of the open source Redis, which comes with a lot of architectural changes for hierarchy, security, and other enterprise functionalities. Redis is very popular. There is millions of downloads for every day, and Redis is one of the top known key value per kind of a database. If you look at this screen, which actually highlight the multi-modeling capabilities Redis has. And by the way, we are going to have another webinar for triggers and function. This is also another adoption for implementing rate limiting in the Redis Enterprise or Redis implementation. And Redis is basically multi-model database, and it's giving you cloud agnostic implementation. It can be as a pay-as-you model across all the public clouds. And these are all the enterprise functionalities for making sure that you use Redis as a primary store and at a production scale, right? And this is the multi-modding capabilities. We probably can have another webinar. We can talk about this. So I'm moving too fast. So using Redis for rate limiting implementation, because Redis is implemented in memory and it is built for performance, you always get all the responses in a millisecond time. You can perform atomic operation using the Lua script or the triggers or the functions that we support today. Redis has a different type of data structure like a list, sorted sets, and hashes, which allows you to use the different types of implementation or types of methods into the Redis. Redis is having time-based expiration, like an example, the expiries of the keys. It allows you to implement the rate limiting per users, and it gives a constant experience whether you have 100 clients or 1 million clients or 10 million clients, right? And there is a different kind of a scale because Redis is a horizontal scale. It can easily scale across multiple shards and gives you the constant performance. So that's all about the theory of the Redis uses in the rate limiting functionalities. And Abhishek is going to take the demos further on this side. Abhishek, over to you.
Thank you, Suyog. Thanks a lot for this insightful session, Suyog. So just quick sound check if I am audible quite well.
Audible. Yeah.
Great. So yeah, before, so here in the second part of this demo of this session, I would be actually talking about implementing rate limiting using Redis, specifically Redis Enterprise. But before that, there are a few considerations we actually want to highlight here, right? As you can see, I think by this time, I hope you have understood why implementing rate limiting is very much critical for your APIs. especially for your customer internet facing apps, right? Having said that, every non-functional requirements, what we call as NFRs, should be addressed appropriately, be it authentication, authorization, rate limiting, HA, scalability, right? Rate limiting, elasticity, I mean, all those things, right? So yeah, so I was actually telling you just concentrate on this red line, which is quite, I mean, we have three types of users here, three types of user traffic here. One is quite very much normal traffic, another one is quite spiky, and other one is actually a kind of right. Another user is actually trying to wreak havoc in your application ecosystem, right? You can just concentrate on this red line. So this is actually transgressing all the limits of your application. So which may inhibit your legitimate user to implement any use case, implement any user traffic and all those things, right? So this means without having rate limiting in your application, right, can have very different response systems for your application side, right? So the one thing I would like to tell you over here is that if you don't have rate limiting over here, any type of, especially in terms of your internet facing applications, any users can wreak havoc, right? Which is why we need to have some sort of a rate limiting or at least a throttling for your APIs. I'll talk about it much deeper into it. Let's concentrate on a different aspect of it. So just think of it a kind of a hypothetical scenario where you are building some sort of a B2B application. So before building some sort of a B2B application, there are certain considerations as well, right? For example, you can have different types of users. I mean, it can be free users, some bespoke users, standard users which are falling into premium types, right? So for that, your team will also be building some sort of a common API. And as a business requirement, you also need to support quota management, API throttling, API metering, and all those things, right? Now, as a typical requirement of API rate limiting and authorization, these are not NFRs anymore. These are not non-functional requirements because this has now translated into your core requirement of your business. Now you want to monetize your APIs, you want to track their consumption, right? So that all different types of users will have a different types of experiences. Simultaneously, you also want to have a flexibility to modify this limit as and when your business demands, right? And because if one of the user is actually falls into the standard domain, their limit would be different. If one user is in the premium domain, their limit would be different. So all in all, different sort of a experience for both of them. Now, last but not the least, you also need to have a performant, mature, scalable, and highly available solution with a proven record. And as a matter of fact, we should not allow infrastructure from maxing out here, right? Because if we do that, that could also have a potential cost implications as well. And one more point to reckon with, what if you are looking to expand beyond boundaries, right? Do you want to have another layer of technology on top of your technical stack? This you can have, but this may complicate the things further, right? So which is why, so here what I'm going to show you, there are two types of user. One can be a standard user, another can be premium user. The request quota per minute could be different for each of these two. And accordingly, the cost per request would be different. So it's a kind of very simplistic example where I would be going to show you how rate limiting can be used to achieve this. Now, so what we are building today is a scalable rate limiting solution in a geo-distributed application with Redis Enterprise. When we say geo-distributed, which means presence of our application in more than one region, more than one location. It can be different countries as well. It can be different location. It can be different set of geographies as well. So before doing that, let's actually first understand, and I assume most of us very well aware of what active-active databases are. And although the implementation may be vendor specific, but an underlying philosophy is bound to be same. And but in everybody's interest, let's devote a couple of minutes to understand what exactly Redis's active-active database is. And without loss of any generality, I'm actually showing you here 3 CRDB clusters. Right. So we have three databases in 3 different locations. It can be region 1, region 2, or region N, whatever. Right. So when we say, when we write anything inside one database, we are writing here in region 1, right? So since it is an active-active database, we should be able to get the same result from other databases as well, right? Because since all these databases are connected by a highly network connections, right? So they would having very much minimal latency between each other. So which is why we can get it from any database. It's quite natural. And likewise, if any database can be configured to listen or configured to write anything inside it. And accordingly, any database can be used to read any value from it. So this is actually the definition of active-active. And the core part is actually promising the latency here, how much latency would be, whether it is eventual, whether it is strong, consistent, and all those things, right? So if you talk about Redis, it promises eventual consistency in a near real-time manner. Right. So let's understand more from this reference architecture. Right? I have used a Google Cloud platform for this demo as a deployment platform, but this doesn't actually stop you to actually use it for any other cloud platform, be it Azure or AWS. So here, Redis is deployed as an active-active database, right? As I said, so each database is connected by a low latency, high-speed connection. Now, you have 2 options to whether how do you use with Pix, basically. You can use Redis Enterprise software, create your active-active database. You have to self-manage that. Or you can use Redis Enterprise as a serverless platform using Redis Enterprise Cloud and any of the cloud providers. Now, we have also deployed our rate limiting application. So this is the actual rate limiting application, a dummy application, which I built in each of these regions. And each instance, so we have deployed this rate limiting application inside an instance group. So there is actually a load balancer. Load balancer is front loading all the user requests, all the different types of users, whether it is standard, free, bespoke, premium, whatever. So load balancer would actually listen on to this traffic, parses this traffic and routes this traffic to the desired service backend. As a service backend, I'm using instance group, as I said, because I'm using Google Cloud Platform. So in each of these regions, I have a specified instance group. And inside this instance group, as I said, we have a rate limiting application deployed in it. Now, how do we connect between this application and the Redis Enterprise cluster? For that, I'm using VPC Pairing connection so that we can able to use the private IP or private link. We don't need to go to the internet to talk to our Redis Enterprise clusters, right? But in a real scenario, if you talk about, there will also be a set of downstream actual APIs, actual core APIs of your application, databases, collection of databases, be it SQL, NoSQL, relational, file store, object store, all those things, caches, right? But these APIs contain, but these are actually the out of scope for this demo, because this is something we are not talking about it, right? So the thing is that the load balancer will intercept every user traffic and send them to the desired location. Let's zoom into our problem, what exactly we are trying to do here. So as I said, the request coming from the load balancer is again intercepted by the rate limiting application, because this is something we have implemented as a pass-through service. All the requests should be intercepted by the rate limiting application. Once it okays it, it will be routed back to the downstream APIs, right? So let's concentrate, let's zoom in into our actual problem. I've just removed all the irrelevant details for this demo. So this is the part which is actually the Redis Enterprise Active, which takes care of storing all the details, all the counters, all the strategies we are following to implement our rate limiting. And this is the pass-through service which we have actually built on Google Cloud. Right? It contains our dummy rate limiting application here. So having said that, let's also understand the solution components before I show you in my demo is that I've built this application using a typical Spring and Java. As I said, Google Cloud Platform is my underlying cloud provider. I've deployed this on multiple regions. So each application points to its local Redis Enterprise database, which provides a local connectivity, right? Local latency. And a simple rate, I have created a simple rate limiting logic using filters and all those things. And I've used a fixed window kind of a strategy over here. That's not the only thing which Redis Enterprise provides. As a bonus, you can call out, as I said, it provides a serverless platform. Plus, it can also be used to externalize your session, right? Think of it in a microservices architecture where you want to scale your stateless application, but want to manage the sessions in a different store. Redis can be used. And how to create a stable connection, you can use Redis Enterprise for that matter. And another aspect is quite interesting is that if you come from the Java background or Spring background, you can integrate Redis with Spring security, and Redis can be an authentication provider, right? Wherein we can authenticate the user, which are trying to log in, right? So I've used that logic as well over here. Last but not the least, Redis Enterprise provides certain other modules, certain other enterprise capabilities, like it provides full text search engine. It provides JSON capability out of the box, wherein it would assist you in building a real-time data modeling capabilities, right? And last but not the least, as I said, it's a kind of, we have deployed as an active. So it's a demo time. Let me show you what exactly I'm trying to do here. So this is something, two instances which I'm running. One is in the Mumbai. This is in the Singapore, right? I've used two regions for this demo to make it quite clear, make it quite simple. I'm using a one command line utility called Redis CLI. If you are aware of it, I will try to make a local connection between with each of these, right? So what I'm going to do, so before going further, this is the repository I am referring to. We have built for this webinar, for this demo. And let's understand what Redis active, how it works, right? The point here I want to make is that I would be adding some data inside database present in Mumbai location, and see it will be replicated in real time in Singapore location, right? So just type monitor and see what actually is happening here. As you can see, there are certain logs. These are actually the sync logs, synchronization logs, or health check logs, which it is received, which it is receiving from their participating other clusters, which is Mumbai. So this shows everything is working fine at this moment. We have 16,384 slots available, all those things. Now let's add some data into it inside our Mumbai location and see what happens instantly. As you can see, in real time, it has actually replicated the data towards the Singapore location in real time. So that is something, the power of Redis Enterprise, and how we can build a typical rate limiting, distributed rate limiting without any consistency issues, right, across boundaries. Let me show that to you as well. Let me stop it first. Okay. So for that, let's talk about this application. So I have, I built one dummy fintech application. So this leverages a subscription-based model, right, to provide its client a lead or contact details of users who are interested in different types of loans, right? So for that, we are leveraging rate limiting concept to build API quota management, and user will be charged based on their plan type. For instance, user who is a kind of a standard user will have will have lesser quota limits than a premium user. And if he wants to switch over or want to upgrade themselves to a premium user, how to do that seamlessly? So it's a small POC. It's not a kind of production grade application, but can provide a food for thought how things like this can be easily created, right? So I have deployed this application, as I said, in Mumbai and Singapore. And I would request Rakila if you can share the URL for everybody to use it. So, this is the URL for Mumbai. And this is the URL for Singapore, right? Let's register. I'm a new user. Let's register. My service plan is $5,000 per month. Let's say my username is Abhishek 007, B007, right? Password is 123. You can also try from your end as well. Click on save. Now what I've done is that I have added a user in Mumbai location. I can also be able to log in the Singapore location as well, because since it is an active database, right? Let's do that. Yeah. Good. As you can see, I'm able to log into the Singapore location as well, because all the login user information has been replicated back to both the clusters, both the participating clusters. And as you can see in this diagram, I am a standard user. I have a quota limit of 5 requests per minute. That's all, right? And right now, the quota which is available to me is 5. Let's submit the request. Right. So it should right now, the quota limit is actually changing. It's changing constantly. And let's see what happens if I go on hitting this submit request again and again. What would happen here? So yeah, at one time, so this result is actually it's a kind of a dummy record, which actually is providing you the details of the users who are interested in loan types, whether it is personal loan, home loan, car loan, whatever, right? Their liability, their credit score, their entire demographic details, all the details, right? And I'm selling this service to my clients. And for that, I need to have a rate limiting in place. So right now, since the client is a standard, I'm a standard user, I can only fire 5 requests per minute. Just an example, that's all. Tomorrow, if I feel I need to increase it further, what do we do now? Let's upgrade it. Just do. So I will be upgraded to 7,500 rupees, dollar per month as a premium plan. Let's confirm it. Now my API plan has been increased to 15 requests per minute. Let's try that if that is actually working out or not. Let's try from here. It's working out, and at some point of time, you can also try from Mumbai location as well, if you want to, because everything is same. Data is actually replicated. At some point of time, you would see API 406 error. Sorry, yeah, 429, not 406. Problem with that, but yeah, the idea is same. So this is something I also wanted to show you how Redis Enterprise cluster, we can deploy it using serverless platform. So yeah, this is my cluster, right? This is my cluster. As you can see, I have deployed the cluster in 2 regions. This is in Mumbai. This one is in Singapore. Both have their public endpoint, private endpoint, individually connected, right? All those things. And how we are connecting from our application to this user is using VPC pairing. We need to have a VPC pair, individual separate VPC connection between these 2 regions. So this application is something what we are actually trying to demonstrate, how rate limiting application can be used to build some sort of a subscription based model for our application here. Right? You can see we are not cross-linking any instance, any rate limiting application to any different regions, right? Okay. That's all I have for today. Over to you, Ratna.
Hey, thanks a lot, Abhishek. Thanks, Suyog. And just to keep you guys informed, these are like more resources which is available. I know there were a lot of questions regarding like the code and all the links. So all of this will be shared post the event as well for you to access. And if you have any questions, feel free to reach out to Abhishek and Suyog. On the chat window, I have put their email IDs and then their LinkedIn IDs as well. So you can feel free to reach out to them post the session. Okay? And there are some questions at this point of time. Suyog, do you?
So, yeah.
Yeah, so there is one question from Uma is what is active scenario for Redis? Does it mean all the regions is active? In that case, how do you resolve conflicts? Is it available only in a Redis enterprise? Last time I explored Redis master slave and master slave with the Sentinel. Okay, so see the Redis enterprise has certain enterprise features, and one of the feature is active support across multiple regions, right? And it's like example, you have applications which you want to serve in a multiple regions, maybe let's example Hong Kong, Singapore, India, maybe in a Mumbai, and then you have your load distribution, or maybe let's example e-commerce side, gaming side, or the open APIs which might be distributed. So in this case, enterprise active scenario makes sense because you'll be implementing rate limiting per user or per API request. And if let's say example, your clients are distributed, meaning that the client applications, let's example, XYZ bank is serving their open API for the customer who might be based off Mumbai, Hyderabad, or maybe Singapore. In that case, they're expecting that the requests are coming. So in this case, yes, enterprise active will be helpful because let's say there are 10 requests came from Mumbai data center and 10 requests came from Singapore data center for the same user account ID, right? So you don't want to basically allow more than 20 requests. In this case, the 20 requests will be allowed, but let's say more requests come for the same user from different data center, it will start throttling those requests. So that's where the active makes sense. Now, in case of Redis Enterprise active, yes, all the sites in the active are going to support writes as well. It means that they are actually going to take read and write traffic, and that's how the counters will be incrementing from the both the data centers, and at the certain limit it will basically start throttling the request. So that's how it will be. There is a question like master slave or master slave Sentinel based implementation. That is a region specific. Imagine that you want to have master slave configuration in the Mumbai level, which means that for a hability point of view, if my master goes down, I can promote my slave or replicas. That is at data center level 1. But what if I also want to support at data center 2, data center 3, which are physically distributed? That's where the active functionality comes in picture. So that you're not only implementing hability across multiple data center, but you're also giving distribution panel supporting this kind of functionalities, right? So it is beyond hability, beyond 2 data center kind of implementation, and allowing you to scale really 1, 2, or 3 kind of a data centers. I hope that answers your question, Uma. There was one more question that is this Redis out-of-box functionality for rate limiting? No. See, Redis has a different types of data structures. Like we talked about, Redis has a PubSub, Redis has a stream, Redis has a list data structure, or simple key value pair counters, right? This allows you to implement rate limiting using Redis as a data store. And imagine you have, let's say example, millions of users, and every users, maybe if they are frequently hitting your database or backend, you want to control this traffic, right? So what you're doing basically, for every user or session or maybe client application, you can create a single key or multiple keys in the Redis, and then you basically have this counter logic on those keys which can be spread. So this, and because Redis is an in-memory solution which is built for performance, is always going to respond back in a micromillisecond, right, for this kind of implementation. So this makes sure that when you have application API requests, it doesn't really impact your overall performance, right? So the first question is, Redis giving our rate limiting out of box? No, it is something you are still implementing, but using Redis as a data structure. And second thing is, because the Redis has the performance and the scale that it can support you, it basically gives you the platform where you can implement this at a scalar level. And because the enterprise feature, which is like a high ability, durability, or multi-region replication, it allows you to scale without changing your code. I hope that answers your question on that front as well. I think there is another question from Karan. Is there a way implementing throttling via Redis cause rate limiting kind of violates the SLA we currently have? Yes. So Karan, in the Redis 7.2, which is the feature we have basically talked about, like Redis triggers and the functions that can allow you to implement some logic at Redis side itself. Meaning that, let's say now you have built per user, I'm going to allow more maximum 10 requests per minute, let's say using the fixed window kind of implementation. But let's say you also want some kind of dynamic logic, that maybe there is a sudden spike, and now you want to basically change that logic. You can use triggers, which can basically trigger some event, and then it automatically update those particular users. Okay, the request coming from, let's say, this type of users, I don't want to allow any traffic, or I want to now reduce down that space, maybe changing the frequency to from, let's say, 1,000 requests to 5,000, or maybe 5,000 to 100. So that's something you can do at Redis side, just basically calling the API and then update those keys or their limits. So you can do that with the triggers. Okay. There is another question. So there is anonymous attendees as well in the session today. Which is better to use in case of fixing requests per minute throttling that API gateways are provided on Redis rate limit? I don't understand this question. Maybe we can.
So yeah, let me answer this. So yeah, if you can actually have a mix and match kind of approach. If you are using API gateways, yes, they actually provide some sort of a throttling. But if you want to have a granular level of control in your APIs, which is not actually a kind of a blanket for all the APIs over there, right? Then you can definitely implement some sort of a pass-through services inside your microservices, for example, as a pass-through service inside your Kubernetes cluster, so that it will route all the traffic via that pass-through service, and you have all the logic of rate limiting over there.
Abhishek, there is one question from Madhav. Which data structures of Redis did you use in, and which rate limiting algorithm did you use in?
Yeah, so it's a fixed window kind of a strategy, which I've used. Is very simple, but we have more advanced versions. Like, for example, we have Leaky Bucket, we have sliding window as well. And if you talk about the data structure, it says that I'm maintaining a counter over here. I'm just incrementing for each and every request which is coming into. So just a kind of a plain, simple string data structure over here. So this is a per user basis. You have to maintain as many counters as you have different types of clients, different types of users over there.
There is another question from this, can we combine rate limit per user and per API endpoint? Yes, you can do that. So example,
yes, you can do that. Yeah.
Let's say I have 5 applications or maybe APIs which are serving different features, and I may have different users who could be, calling this API. So what you can do basically when you implement any sliding window or fixed window, you can actually create a single key, and because Redis is a key value pair, you can create key combination of user ID and the endpoint. So example, Suyog : API 1, Suyog colon
Yeah.
API 2, and then you can implement what is the API request that Suyog can make for that API, maybe 10 requests or 20 requests, and then you can control that based on the request goes. So you can do that as well. Okay.
Hey, guys, I have Upendra raise his hand. I'm just allowing him to talk.
Sure.
Upendra, you can unmute yourself and talk. Yeah, while he is joining, we can. Okay.
Anyone else
I have-
want to open up and ask question?
There is one, I think there's one question, is this support, which says, is this supported with Bucket4j? Yes, it's if you don't want to implement yourself, there are lots of open source libraries which are available, will actually provide you. And those libraries very well integrate with Redis Enterprise as well. So yes, you can do it. Yes, we have Redis available for on-premise deployments as well. You can use Redis Enterprise software.
There are some questions coming on the chat window as well. Pranjali Sharma has asked, is Bucket4j is a good option for token-based rate limiting?
Yeah, you need to look at to it, because what I got to know is that Bucket4j is a very good open source library which actually assists you in building rate limiting. But what are the different strategies is support is something we need to see into the documentation here.
And there are some more questions from Robin S. How do we do VPC pairing with Redis, considering we are using Redis Enterprise and AWS setup, just to keep everything into one VPC, please
VPC.
advise.
Okay, so so you have two options, right? If you are using AWS, I think you are using AWS, Robin. So what you can do, either you deploy your Redis Enterprise in the same VPC in which your application is deployed, or as a second option, you can have another VPC which deploys your Redis Enterprise cluster. And once you have that, you can create a VPC pairing connection between these two VPCs. Either ways is fine. Whether you want to deploy it in the same VPC, it can be done, or in a different VPC, it can be done. It's just that if you want to deploy it in the same VPC, you have to use Redis Enterprise software for that matter. So which is why it is quite interesting and quite useful for you to use Redis Enterprise Cloud. To just you don't need to worry about any intricacies, any details about managing or maintaining your clusters, right?
The more questions coming. Sorry, Abhishek, if you want to complete that answer.
I think what's the cost of Redis Enterprise software for self-hosted version? I think you can check it on our page, redis.com. So we follow shard-based licensing model over there. It depends upon your use cases, what exactly is your use case. For example, how much data you want to store, how much throughput you are looking for. So based on this, you can actually, and there are a few other details as well, which is actually required before selecting the right shards. But yeah, you can just go over our product page.
There's a question from Venkatarao that does Redis support on premises? So yes, Redis does support. It's basically nothing but running on a Linux operating system. It can be deployed in the bare metal machines or virtual machines or the containers, whether it is on-premise or on the cloud. If you look at the Redis Enterprise, we have pay-as-you model on all public cloud, AWS, GCP, and Azure, and it does support in the the containers as well. On premises, we have Redis Enterprise software, which is coming with all the enterprise functionalities, and you can deploy them in bare metal machines, virtual machines, or the containers. Example, OpenShift, maybe Tanzu, and plain vanilla Kubernetes as well. So you can go to our redis.com website and look at the options that you want to deploy, and probably you can touch base with us on the email as well, so we can help you in the right answers, right? There's a question from Chirag, I guess. What is cost for Redis Enterprise software for self-hosted version?
Yeah, I've answered that.
Okay. Perfect. Okay. How throttling at rate limiting differ? I don't understand your question, Shreya. If you want to take on audio and ask this question in more detail. Shreya, are you there?
Can we set dynamic API rate limiting as per traffic? Yes, you can. I just showed you in my demo, right? Based on the traffic, based on the user type, based on your requirement, you can do it on the fly.
Okay, we have Shreya on the line. Yep.
Yes.
I read your answer for what is throttling. So I did not understand that how is like what is the difference between throttling and rate limiting?
Yeah, so rate limiting is the one of the method to throttle the request, meaning that let's say my capacity to serve requests is 100 requests per minute or 100 requests at a time. So if there is a lot of traffic is coming, I want to throttle the request, meaning that I want to deny that request more than 100. So that's what the throttling. Throttling is basically the problem, and rate limiting is the solution to throttle the request. I hope that answers your question.
So basically, rate limiting is more granular level and very difficult to achieve at times, because as opposed to throttling, because throttling actually works at the server level wherein you want to normalize the traffic. You don't want to overwhelm the server in general for any types of traffic which it is actually receiving. Rate limiting is actually works on per client basis, right?
Okay, so are there any other ways of handling the throttling problem?
So we have also certain tools available, and as also Suyog mentioned it out, you may have certain things in place in your application architecture which can also assist in throttling as well. But that would be a kind of a blanket kind of a solution for all the users. So you need to be aware of whether you need throttling or you need rate limiting for your application.
Throttling is just increased traffic, right?
Smoothing out your traffic, right? So that your servers are not overwhelmed by the sudden spikes in the traffic and all these things.
Okay, cool.
We also have Navdeep who had raised his hand. I've allowed him to talk.
Yeah, thanks for. As you mentioned, there the rate limiting is can be applied on the server level or the like network level. That you can give me some guidance on that. On which level we need to apply on that?
The rate limiting actually works on a request level, API level, right? It works on the API level. How, like for example, you are designing an API which can only promise, let's say, 5,000 requests per second as a right, not more than that. Beyond which you can, your auto scale environment can trigger, which can also lead to cost implications as well. So whatever you are, how you have designed your API, whether it is for internet facing or for internal traffic, you need to have a rate limiting in place. So that because a sudden or any DDoS attack, which your API is actually, if a user is trying to do, they will not overwhelm your underlying servers. That's actually the philosophy. You should have because I think we have rate limiting for all the public facing APIs. You talk about all the services from Google, right? It has rate limiting. Any other APIs who are actually providing the service, any product based service, they are having the rate limiting. And what I've shown in this demo as well, how can this be used to monetize your API? Because companies are also doing it to monetize their APIs. They want to have different sets of users. One could be standard, premium, and they can have different type of quota for each set of users. The same API can have different quota limit for different types of users.
Okay. So what I understand, before going to the API level, there's another channel where we can limit the request, and it will be happen
For all
on
the for all the users.
Okay, fine, thank you.
There is a question from Srinivas. What is the maximum number of requests per client we can rate limit using Redis? This is completely depends on your application logic and how much requests your backend is going to support, right? And Redis is basically just middleware who are implementing rate limit. Now, if you're asking like in the Redis how many counters or how many requests for implementing rate limiting I can do. Then there is a question, answer is basically unlimited. It depends on how many operations. So basically our customer who use Redis for implementing Redis for different use cases, including the caching, rate limiting, or primary or other use cases, they simply use Redis for millions of operation per second. So if you have application which is, let's example, going to serve gaming use case, right, which has mostly kind of a traffic of millions of TPS to Redis, you can do. And again, it's like, Redis does support vertical scale as well as a horizontal scale, meaning that you can set up the service in the Redis on AWS saying that I want to serve traffic of, let's say, 10,000 TPS, and let's say my dataset size is 10 GB. But let's say some XYZ, your business is growing, your feature is working great, and you suddenly expect traffic to go 100,000 or maybe 1 million. You just go and change that TPS. Redis Enterprise will internally, going to require provision those required nodes and shard for you, and then you can basically do that without taking any downtime to your service. I hope that answers your question, Srinivas. Cool.
There are some questions from Neeraj here. If we can implement rate limiting on server without using Redis, then what is Redis benefit to you? Like you use it? And a follow-up the same, is it beneficial for microservices or monolithic applications?
Yeah, so Redis is again like, here used as a data structure solving the rate limiting use case. Okay. Please don't get misunderstood that Redis is a serving rate limiting function. It is providing the data structures and the scale to implement this, irrespective whether your backends are implemented in a microservices or monolithic architectures, right? So what you're basically saying that I have microservices implementations and I can actually scale serving traffic to, let's say, from 10 microservices to 100 microservices, meaning that I can serve minimum 5,000 requests, and at the end, let's example, if I scale at peak 100,000 requests. So what you're basically implementing that you will implement that per user how many requests, and if you see that there is a peak happening, meaning that there is more requests coming, you will trigger your backend to support more. You basically increasing your more microservices to scale up, and then you changing that your rate limiting window maybe instead of let's say example 100 requests per second to let's say example 1,000, right? So that's how basically you are trying to map the backend systems to what you can do, and then control that counters into the Redis, and then whenever the new requests come, you check into Redis that this user, how much requests I can serve at this moment, or can I serve this request right now.
Great. I know we are over time, but we have like an enthusiastic crowd with like a lot of questions. Is there any last questions that Abhishek and Suyog, you guys want to take?
There's one question from Venkat that he want to know that Redis support on Windows. No. So Redis Enterprise or Redis Open Source doesn't support on Windows. It is by design, and we don't have an immediate plan to support on Windows. But you can always use, if you are on a public cloud or if you are on a on-premises, you can always provision Linux operating system. And if you go to our doc site, there is a supported platform you can do. We have some customer who virtualize Linux operating system on the Windows to put Redis. But I recommend, if you really want best results, go with separate machines for Redis implementation, which is actually Linux based. Okay, I hope that answers your question, Venkat.
Great. Any last questions, team?
Can we? There is a question from Anush. Can we write Lua script in the Redis for conditional rate limiting logic implement? Absolutely, yes. But remember that Lua is only limited to specific Redis shard process. So if you're implementing sharded or cluster Redis, in this case, you have to make sure that per user or per API that you're creating those keys are based on the same shard. There is a, as I mentioned, that we are added feature for triggers and function. I think triggers and functions are right implementation for a scale level, because functions support Redis clustered implementation, meaning that it allows you to really scale across multiple shards as well. So probably you can look at the Redis functions, which might also be interesting. But yes, to answer your question, yes, you can use Lua script as well. Okay, I think so. We are good. We have seen some question, but maybe we can reply them over the emails.
Yes, and also team, as I mentioned previously on the chat, I have mentioned Suyog's and Abhishek's email ID and LinkedIn profiles. Please feel free to share with them any questions or anything, and they are like experts from Redis in the region, and they can help you on anything. Yep. Thank you so much for the session. Thanks, Abhishek. Thanks, Suyog. Hope you all had a good time. Have a good day, guys. Bye.
Thank you. Have a good day. Bye-bye.